Hello, this is Changster. Welcome to my video on probability of independent and dependent events. First of all, let's review some concepts before learning more about the topic. We will first look at compound events. A compound event consists of two or more events. If you can think of some examples, this might include flipping two coins, rolling three number cubes, and spinning two different types of spinner. Let's look at our first example. You spin a number spinner and a color spinner as shown. What is the probability of spinning an even number and green? When you spin the number spinner, you get numbers between 1 to 5. When you spin the color spinner, you get 4 possible colors of red, blue, green, and yellow. To find the probability, we can first take a look at the possible outcomes. Using the fundamental counting principle, we know that the total number of possible outcomes is 5 times 4, and that gives us 20 possible outcomes. We can use a table to find the sample space, which is the set of all possible outcomes. In this example, using a table allows us to list the possible outcomes efficiently. I will first draw a table and divide it into 6 columns because one for each number. So I have number 1, 2, 3, 4, 5 for the 5 possible outcomes for the number spinner. And for the column here, I will put the 4 different colors. I'll start with red, and I'll have red and then blue, green, and yellow. So one possible outcome will be 1 and red, and next one will be 1 and blue, 1 and green, 1 and yellow, and you have 2 and red, 2 and blue, 2 and green, 2 and yellow, 3 and red, 3 and blue, 3 and green, 3 and yellow, and we have 4 and red, 4 and blue, 4 and green, 4 and yellow, 5 and red, 5 and blue, 5 and green, and 5 and yellow. You can see that all the 20 possible outcomes are listed very clearly in this table. Now we want to see what the favorable outcomes are. So the favorable outcomes will be the ones that we're looking for, an even number and green. So I'm looking at even number and green. So we know that 2 and 4 are the even numbers in this case. And we're looking at 2 and green. So this is 2 and green and 4 and green. So out of here, we can see that there are 2 possible outcomes that we want in this example. Do you remember how to find the probability of an event? The probability of an event is equal to the number of favorable outcomes divided by the number of possible outcomes. In this example, we want the probability of even and green. So in this case, there are 2 possible outcomes of even and green, and the total number of possible outcomes is equal to 20. So you get 2 over 20 as your probability. We will simplify the fraction to give us 1/10. And that's the probability of getting an even number and green. Next, we will look at independent and dependent events. Compound events can be independent events or dependent events. Events are independent events if the occurrence of one event does not affect the likelihood that the other events will occur. Events are dependent events if the occurrence of one event does affect the likelihood that the other events will occur. We will now look at our first example. Is it an independent or dependent event? Does spinning a certain number on the first spinner affect the color that you might obtain on the second spinner? Pause the video to think about it. This is an independent event because the result of each spinner does not affect the other. From our work earlier, we know that the probability of getting an even and green is equal to 1 over 10. Now we'll look at the probability of each event. So for the number spinner, the probability of getting an even number, as you can see, there are two even numbers, 2 and 4. So there's 2 out of the total possibility of 5. And for the color spinner, we have probability of getting green, which is equal to 1 out of 4. And from here, when I multiply 2/5 by 1/4, you can see that you end up with 2 over 20, and that gives us 1 over 10, which is the same as the probability that we worked out from our previous example. Events that are independent, you can take the product of the probabilities of events. So in this case, P probability of even and green is equal to probability of even times probability of green. So in this case is 2/5 times 1/4, and you get 1/10. This brings us to our key idea. The probability of 2 or more independent events is the product of the probabilities of the events. In symbols, we write it as probability of A and B is equal to probability of A times probability of B. Probability of A and B and C is equal to the probability of A times probability of B times the probability of C. Now let's look at our second example. A bag contains 2 red marbles, 3 blue marbles, and 1 green marble. You randomly draw 1 marble, put it back, and draw a second marble. What is the probability of drawing 2 red marbles? If it's helpful for you, making a sketch may help you see and understand the problem better. But don't spend too much time in the drawing. Alright, so or you can even use like the letter R for 2 red, and blue, B for blue, and then G for green. So here you can see that altogether there are 6 marbles. So the probability of drawing a red marble will be, so I'm going to use red. So probability of drawing red will be equals to the number of red over the total number of marbles would be 2 over 6, you get 1/3. Okay, so now think about this event, whether this drawing the 2 marbles is independent or a dependent event. So will the first draw outcome affect the outcome that you get for the second one? The answer is no. So the probability of getting 2 reds, or the probability of getting red will be equal to the probability of red times the probability of red. So will be 1/3 times 1/3, and that gives you 1 over 9. We can also use a tree diagram to help us solve this problem. You will label the first draw, and then the second draw. So you will have the 3 possible outcomes. We have the red, the green, and the blue. And then after you draw red, you can draw red again, you can draw blue again, you can draw green again, and then here you can have red again, blue, and then green, and then we have red, blue, and then green again. So the first draw, the probability of drawing red will be 2 out of 6. I will just leave it without simplifying and we'll see why I do that. And the green will be 1 out of 6 and blue will be 3 out of 6. Okay. When I draw a tree diagram, I'm not usually in a hurry to reduce the fractions. Okay, and here to get another red, I'll change the color to blue maybe, so I get 2 over 6 again, 1 over 6, and here I get 3 over 6. Here I'll get same thing, 2 over 6, 1 over 6, and 3 over 6. And for this I'll get the red again is 2 over 6, this blue is 1 over 6, and I get 3 over 6 here. 3 over 6. If you could see, if I want 2 reds, what I want will be this 2, right? So 2, 6 here. So you will do probability of red is equals to 2, 6 times 2, 6. Okay, and then you can simplify that to give you 4 over 36, and that is equals to 1 over 9. Now you can see that it's a lot easier using the first method when you know that the two events are independent and you can just multiply out their probabilities. The tree diagram method is another way, it's just that it's not so efficient for this example. Let's look at our third example. A bag contains 2 red marbles, 3 blue marbles, and 1 green marble. You randomly draw 1 marble. Without putting it back, you draw a second marble. What is the probability of drawing 2 red marbles? I would like you to think about whether these 2 events are independent or dependent events. Does drawing a first red marble affect the likelihood of drawing the second red marble? Pause the video to think about it. These 2 events are dependent events because when you draw a marble out of the bag, the total number of marbles left will be fewer, and also the number of marbles of whichever color drawn will be fewer also. Let's take a look. And in this example, drawing a tree diagram will be very, very helpful. So let me show it to you. So you have your first draw, and then you have your second draw. All right, so I'm going to start with the first branch. You have your red, and then we have the blue, and we have green. So you have those 3 probability. Now the first draw, there are 2 red marbles, so 2, and the total number of marbles in the bag is 6, so 2 out of 6. For blue, we have 3 out of 6. And for green, we have 1 out of 6. Now, let's look at the second draw. After you draw 1 red, okay, and then after you draw 1 red color, how many red is left? You will have 1 left. So it will be 1, and the total number of marbles left will be 1, it will be 5. So you get 1 out of 5. And for blue, you end up with still 3, but it's 3 out of 5 because you have 5 marbles left. And for green, it will be still 1, but it's out of 5. So after you draw the first blue, you will have red and blue and green again. So the probability of drawing a red after you draw a blue and not replacing the blue back into the bag will be, so you will have 2 red left, and then you end up with 5, and 2/5, and for blue, since you already drawn one out, you're left with 2 blue over 5, and for green is still 1 out of 5. Now let's look at what happened after you draw out one green. So let's look at the red, the blue, and the green. So after you draw out one green, you end up with 2 reds out of 5, and for blue color it will be still 3 out of 5, and after you draw out one green, you're actually left with no green, so 0 out of 5. In case you're wondering how I got a total of 5 in my second draw, let me show it to you. We started with 2 reds, and there are 3 blues and 1 green. So when you draw the first red, say this one is taken out, this first red is taken out from the back, so this will be the total number left. So over here you can see that there are 1, 2, 3, 4, 5 marbles, and it's only 1 red marble. So that's why you have 1 out of 5 here for this second draw. And to draw the blue marbles, you can see that I have 3 of them here, 1, 2, 3, and that's why I have 3 out of 5 for the second draw for blue. And for the green, I have 1 green left, so it's 1 out of 5 here. So the probability of drawing 2 red marbles here will be the probability of drawing the first red multiplied by the probability of drawing the second red. The probability of drawing 2 red marbles will be the probability of the first red multiplied by the probability of the second red after the first red. So if you use the tree diagram, it's very straightforward. You just take 2 over 6 multiply by 1/5, and that will give you 2 over 30, and that is reduced to 1 over 15. So our key idea for probability of dependent events is that the probability of 2 dependent events A and B is the probability of A times the probability of B after A occurs. So in symbols, P of A and B is equals to probability of A times probability of B after A. Looking at our previous example, you need to look at the total number of possible outcomes after A occurs and the total number of outcomes after A occurs. We have reached the end of my video. Thank you for watching. I hope that you have enjoyed it and learned much about the topic. Don't forget to subscribe to my channel, and I will see you again for another lesson. Bye.